we are going to learn how to solve these equations with exponents where we can't use our powers chart, using something called a logarithm. So time you've learned something in math, a little bit later you've learned how to undo it or do its inverse. The first thing you learned in like kindergarten grade 1 was adding. That was the first math thing you learned after counting, but your first operation. What's the opposite of adding? Subtracting. So after you learned adding, you learned how to undo it by subtracting. Then you learned multiplying. A little bit later, you learned dividing. You learned how to get rid of it. And all the way through, we've been learning how to do certain things and then to undo them. The first time you had something weird with solving was probably with exponents. And like something like x squared. What's the opposite? Whoa. What's the opposite of squaring? Square rooting. And you had this is kind of that was a weird symbol when you first learned it. It's like, that's a math thing? And of course, because you also learned the plus or minus in front. So then you would get plus or minus 3. You learned to square root sign. So the question is, what's the opposite of that? What undoes x as an exponent? And we're going to learn it's a logarithm. And we're going to start by figuring out what this logarithm looks like. So if I took something like 10 to the x, which is the graph right here, and I wanted to undo it, undoing something is an inverse. And we've already learned about inverses in our first chapter. Remember, an inverse was a reflection, over the line y equals x. And all you do is take your x and y coordinates and switch them. So if I took 10 to the x and I switched all the x's and y's and flipped it over that diagonal line, y equals x, I would get y equals 10. And this equation, we're going to type it in as y equals log base 10 of x. And this is called the common logarithm. It's the log button on your calculator. The common logarithm, they decided not to write any number here. Hidden there is, if you see log x, there's a little 10 that's written there that you don't have to write. All the other ones, if I want to do the inverse of 2 to the x, I would get log 2 of x, and I'd have to write that little 2. So this is the inverse of it. How does it work? Well, if I go to my calculator and I wanted to solve 10 to the x equals 70, I can now just do log of 70. Get 1.845, and I can double check it. It's 10 to that answer, 1.845. Is that equal to 70? It is, exactly. So now we also have a button in our calculator that does all that math for us. Because the only thing we could do if we were doing this right now with our calculator is we could guess and check, right? You'd be like, well, I know that 10 squared is 100, and I know that 10 to the 1 is 10. So if I wanted 70, I'm guessing, right? Maybe you guess 1.7. Well, that's not high enough, so then you go higher. 1.9. Oh, that's too high. So then you would keep guessing and checking until you got to 7. But now we're going to have a button on our calculator that has all those values memorized and can figure it out. So these are things that you know. That 10 to the 0 is 1, 10 to the 1 is 10, 10 squared is 100. So on logarithms, Log 10 of 10 is 1. Log 10 of 100 is 2. And the way that I think of logarithms is logarithms are to solve exponents. So if you had this, you could use your powers chart and right away say that x equals 2. When we write a logarithm, and this is going to take a while for us to get used to, so you're going to have to say, what does a logarithm mean? When I have log 10 of 100, the 10 that's here is the same as the base that's there. Logarithms solve for exponents, so sometimes I put a little tiny question mark there, or attempt to make a question mark, and ask myself, 10 to what question mark would be 100? This is the same idea as this. The logarithms solve for exponents. So one of the ways that we can get and really get to understand logarithms is by using the definition of a logarithm. And I'll get you to write this at the bottom of the page. For every exponential form that you have, you can write it in logarithmic form. So example, we wrote down 10 squared is 100. In log form, that's like saying log base 10 of 100 is equal to 2. And the reason logarithms are there is they help us solve for exponents. So if I gave you like 3 to what power is 52? That's not on any powers chart. In log form, this would be the same as saying log base 3 of 52 is equal to x. And some of your calculators will allow you to type in log 3 of 52, and some will not, which will solve that problem a little bit later. But on my calculator, I can type in log base 3 of 52. And it tells me the exponent would have to be 3.5965777027 for that to work. So logarithms are going to be really helpful if we can use our calculator to solve for x as an exponent. And if your calculator doesn't have log base 3, log base 7, it's okay, because your calculator will have the log button and the natural log button, which we'll get to in a second as well. So at the beginning right now, we just have to really get a good understanding of this definition of the derivative. Anytime you have exponential form, you can write it as log form. Anytime you have log form, you can write it as exponential form. So the starting part now, we're just going to be like developing skills in working with this. So when we get to real life word problems and actually solving equations, we have a good skill base to do that. So example number 1. You've got a whole bunch of exponential expressions. Can you use the definition and write them in log form? Look at the definition. Right? Here's, I'll rewrite the definition for you here. Base to any exponent, that's exponential form. The log form, the base of the log is the same as the base of the exponent. I always remember that logarithms solve for exponents, so I know that the x is over there, which means the y would be there. So in part A, you have the exponential form. Can you write this one in log form? Well, the base of the exponent is 3, so the base of our log is 3. Log solve for exponents, so the 3 will be over there, and 27 will be inside. And I find understanding the definition of a logarithm, because you understand exponents way better than you understand logarithms. So when I see this, I'm actually saying to myself, oh, log 3 of 27. And the next thing I'll say is, if I imagine a little question mark there, this is like saying 3 to what exponent is 27? When someone says, what's log of 3 of 27? I'm like, oh, 3 to what exponent would be 27? The answer would be 3. 5 to the negative 2 is 1 over 25. So if I write this as a log, the base is 5 just because the base is 5 there. Log solve for exponents will equal minus 2, and I will have 1 over 25 inside. And I see log 5 of 1 over 25, and my brain would say, oh, this means 5 to what exponent is 1 over 25? The exponent would have to be negative 2. And finally, 4 to the 0 is equal to 1. So in logarithms, this would mean log, the base is 4, the answer is 0. Log 4 of 1 is equal to 0. And this is asking 4 to what exponent is equal to 1? The answer would have to be 0. What's log 7 of 1? Seven to what exponent would be 1?
0.
0. Log 12 of 1. 12 to what exponent would be 1? 0. Does it make sense that log of any base of 1 is going to be 0? Here, I'll give you a quick mental math. Tell me what that's equal to. 1. Because you're thinking, what would the exponent be? So 5 to an exponent is equal to 5? It'd have to equal 1. Can you see how thinking that way is going to help you evaluate logarithms? Because you're used to exponents, but the log form, when you see it, right now it means nothing to you. You're like, I see a log, I think of a tree, that's my extent of this right now, but I don't think of anything else. Because this is confusing looking. But if we think of it this way, it's going to make our life easy. Okay, part B. Now we need to write this in exponential form. The base of the log is 7, so the base of your exponent is 7. Logs solve for exponents, so the exponent is 2. Seven squared equals 49. True or false? True. Okay. Does your brain look at the log one, though, and say true right away? Log 749 is 2? Whew. Right? Not yet. But this is where we're developing our ideas of what does this new notation mean. Log 4 of 1 over 64, does it make sense that it's negative 3? Well, let's look at exponential form. The base would be 4. The exponent, negative 3. Negative exponent, that would be 1 over 4 cubed. And 4 cubed is 64. And 3 base is 10, the exponent is negative 4. Those would be the exponential forms for each of those. All right, circle questions 5, 6, and 8.